Okay, now in this last video I'm going to try to give you some tips on how to calculate cover by species using the Daubenmire plot. This is probably not the perfect way to do it, but it's a fairly simple, straightforward method. Let's go back to our data set. We are going to go to this data set right here. Here's our Daubenmire plots. Remember, we just finished nested frequency. Now we're going to look at Daubenmire. A couple things about this data set. I'm going to first know that I have to calculate by species. So first thing I'm going to do is I'm going to just sort this data set by species. Cover the whole area, click data, click sort. I do have a header. I want to sort by species code. Great. So now it's in order by species code. Now, recall when we were in the field, if we entered a 0, that meant there was nothing in the plot. If we entered a 1, it meant that species occurred in the first plot. I'm sorry, in the first cover class, which was from 0 to 5. The midpoint of 0 to 5 is 2.5, so we need to replace all the 1s with 2.5s. So I'll show you that that doesn't work, but I have a workaround for it. So I'm going to show you first why that doesn't work. If I find and replace all of the 1s with 2.5, because that's the midpoint for that category, replace 100 of them. That's fine. Here you see, here's a 1 that was replaced with a 2.5. Here's another one. So those are all 1s in the original data set. Let's see what happens when we replace the 2s. Find and replace all of the 2s in the data set with the midpoint for category 2, which is 15. Now, this used to be a 2.5, and now it's a 15.5 because we replaced all the 2s with 15s. Okay, that really does mess up the cover classes. So I have another method that is a pretty good workaround. So I'm going to go back until I get to the original data set. There's the original data set. Now I'm going to replace all of the 1s with A's this time. So I'm going to 1s with A's, 2s with B's, 3s I'm going to replace with C's, 4s I'm going to replace with D's, 5s with E's. This gets rid of that problem of replacing numbers because now I'm converting them to letters. So to accomplish this, I'm going to highlight the area I want things replaced in, and I'm going to find and replace. I'm going to replace all of the 1s with A's. I'm going to replace all the 2s. You see the 1s were replaced with A's. I'm going to replace all the 2s with B's. I'm going to replace all the 3s with, let's get that right now, 37.5. I'm sorry, all the 3s with C's. All of the D's. I'm sorry, all of the 4s with D's. All of the 5s with E's, and all of the 6s with F's. I don't know if there were any 6s, but we'll know now. Yeah, there was one. Okay, fine. So now we have all numbers and zeros in our data set. We can do one more replacement. Now let's replace those letters with the midpoint. So let's replace all the A's with 2.5. Let's work with 2.5. Place all of them. 100 replacements. All the B's we're going to replace with 15 because that's the midpoint for that second to the smallest category, the 5 to 25 category. The C's we're going to replace with 37.5. The D's we're going to replace with 62.5. The E's we're going to replace with 85. And the F's will replace with 97.5. And if I've got it right, there should only be one of those. Okay, that's it. There's just one. Now, all of our letters are now replaced with the appropriate categories. So now we can start doing some averages. One thing I want to point out. At this point, you could do what I did before, which is highlight an area. What I did before with the nested frequency, that is. You could highlight an area for a plant, and you could calculate the average of everything of all of those 5 lines. Okay, remember one thing. There are 5 lines for the plants. For each possible, the plant could have possibly occurred on 5 lines. But for some species, we only have, in this case, we have 3. It was only found on line 1, 4, and 5. It was not found on line 2 and 3. So to make a really true data set, we'd have to have Achillea on these lines also, and that would have to be a 0, because it didn't occur there, but zeros are numbers. They're real numbers. It tells us something when something did not occur somewhere. So in order to get a true average for each of these lines, we would have to have 5 lines for every species. Okay, I'm going to show you a workaround for that. That is called a pivot table. Just remember that we're going to have 5 observations for every point, and we're going to do that just by entering a 5. In order to get the average of all of these lines, I'm going to create a new variable called average. And what this will be is the average cover for all of the acme found on line 1. All of the Achillea found on line 1. And there it is, 1667. And I'm going to copy that down so I know what the average of each species observed on each line is. I'm going to change the format of these just so I can see them. I'm going to format each cell with 2. There we go, 2 points beyond the decimal. Now, I want you to kind of keep track of what's going on here. If I want to know what the average Achillea on the site is, I have 5 examples of it. I have 5 lines. So I could create an average of those 5 lines, and these are in actual percentages, and 0.47 is what it would be. So the average cover for Achillea millefolium on our site with 5 lines as the variable is 0.47. Okay, that would take a while to do. Here's another alternative to adding 5 lines for every species, and create a pivot table. To create a pivot table, you just highlight the area that has all the data you're going to need. It could be the whole data set, it could be the whole sheet, but just highlight the areas that you need, the area that has the data. Insert a pivot table. It's under the Insert tab, way far left. It already finds the area that you've highlighted. We're going to put it in a new worksheet and say OK. Now I know I want it to do this analysis by species, and I know I'm interested in the average cover per line. Okay, notice that this says sum. That's important. This is good for us. We want the sum of all the lines that we observed. There is a way to change that for example, you could change that to a count or an average or a max or a min, but in this case we actually do want sum. It always defaults to sum. So here's the deal. One thing you should know about pivot tables is they're kind of hard to deal with because they're when you use formulas inside of them, they just don't work right because they're always going back to the original data set. So if you're going to use data in a pivot table, it's easiest just to move it to a new area and paste it as values. So now here are those same numbers, but now instead of being a value that is based on another spreadsheet, they're really just values that you have a lot of control over now. So now I'm going to format that cell so that it has 2 decimals beyond the data, 2 points beyond the data set. Now here, this is average cover per line. No, this is average cover total, and this is species. So in other words, this is all the cover that was observed in all of the lines. Okay. So again, this is all of the coverage this is the average cover found in each of the lines. Let's go back and see what that is. So if I took the total cover in all of those lines, it should equal 2.33. So it's the total of all the averages. So if we want to know what the average of the whole plot is, we know that we had 5 lines. We can take this average of the lines that had data and divide it by 5. That's 4.67. So let's get that down to 2 decimal places there. 4.7. Notice I had 4.7 here. When I took the average of all lines, including zeros, including lines that had zeros, I had 4.7. If I take now the average of all the lines, sum of the averages divided by 5, knowing I had 5 lines, I should get that percentage that is the average per line or the average cover on the plots. So that is the true average. This is the sum of the averages, and that's the average. So now I have something I can compare to my nested frequency. I have species and I have a variable for frequency. Remember, we used the 50 by 50 meter plot. That's plot size 4. So if you want to compare frequency to cover, you need to use that plot size. So there it is. That's your cover. You can compare it to frequency. It's by species, and I hope that helps you figure out how to do how to analyze Daubenmire cover plots.